Alright, hi everyone, welcome back to another video on our channel. Today we'll be going through a word problem in one of the topics we learned in our crash course on arithmetic progression and geometric progression. So let's get right into the question. So the preamble of the question is as follows. So to purchase a grand piano, Ken took a loan of $12,000 from a finance company on the 1st of October 2019. The company charges a compound interest at a rate of 0.5% on the outstanding amount owed on the last day of every month, while Ken decides to repay the loan by paying back a fixed installment of P dollars. So this P dollars is fixed on the first day of each month, starting from the 1st of November 2019. So let's say we want to find out what the installment P is when he wants to repay after, say, 12 installments. So do pause this video and give this question a try, and after you're done, we'll come back with the work solution. Alright, so the essential trick when dealing with this kind of word problems is to be careful in transcribing the words in equation form. So the words in the preamble, we have to be really careful in transcribing them into and writing it down on our paper. So let's say we want to find out the installment P after 12 installments, right? So what we can do is we can start by writing it out in a table, starting from the start of the first month. So we call this month 0. So at the start of the month, he has 12,000. He owes $12,000, and at the end of the month, he owes the original $12,000 multiplied by 1.005 because the company charges a compound interest at a rate of 0.5%. Okay, so the numbers in each of these boxes will mean how much he owes the company at that point in time. So at the 12th month, we hope that and on the first of the 12th month, this number is 0. Okay, so let's investigate further. So at the start of the first month, he repays the loan by paying back a fixed installment of P dollars, right? So since he owes 12,000 times 1.005 at the end of October, so at the start of October, he owes P less than that because he pays back P dollars. And then after that, we multiply by 1.005, and then at the start of the second month, we subtract P again, so on and so forth. So we do see a pattern of multiplying by 1.005, then subtracting P, then repeating that, right? So let's try and investigate the pattern. So what we can do is, since we want the number at the first of the 12th month to become 0, we can investigate this number over here. So these numbers over here. So at the start, it is 12,000. And then we multiply by 1.05 and then subtract P, right? Okay, then we multiply by 1.05 and subtract P again. So we can kind of follow this same pattern until we reach the 12th month. So what we can do is we can try to expand this thing out. So we start by multiplying by 1.005, right? See? So we multiply this whole thing by 1.005, we get 12,000 times 1.005 squared minus, we have to multiply this by 1.005 too, so minus 1.005 P. And then we want to subtract another P again. Okay, now this is at the start of the second month. How about the start of the third month? At the start of the third month, we multiply this whole thing by 1.005 again, right? So it becomes 12,000 times 1.005 cubed minus 1.005 squared P minus minus 1.005 P. Sorry, it's a bit of problem with my pen. Let me try and erase it. Alright, so getting back to the question. So we write 1.005 P, and then at the end of the month, we subtract another P. Right, so let's compare the start of the second month and the start of the third month. This power changed to 3, right? And at first we had this 1.005 P minus P. Now we kind of have the same thing at the back, but we added a 1.005 squared P. So we kind of do see a pattern coming up, right? We start with P, then now we have 1.005 P, and And then now we have 1.005 squared p, 1.005p and p. So it seems like every single time we are adding a term containing p with a power of 1.005 that is 1 power higher than before. And as for the part in front, the power for 1.005 just keeps increasing from 1 to 2 to 3, so on and so forth. So we can kind of deduce some kind of pattern over here, right? So at the start of the 12th month, the beginning should be 12,000 times 1.005 to the power of 12. So let's write that down. So start of 12th month, 12,000 multiplied by 1.005 to the power of 12. Okay, now let's look at the other part. Okay, so here we have p for the first month, 1.005p, kind of subtracting this whole thing added up, all these terms added up together. So at the second month, we have the highest power of 1.005 is 1. At the third month, the highest power of 1.005 is 2. So it's kind of 1 less than the number of the month, right? So we can write it something like this, 1.005 to the power of 11, p plus 1.005 to the power of 10p plus all the way to p, because we stop at p, right? And now what we can do, right, is we can actually factorize out p from this bracket over here. So we will get 12,000 times this minus p multiplied by 1 plus, I'm just changing the order, flipping the order, so get this. So next we realize, right, that this thing in the bracket over here is actually the sum of the first 12 terms of a GP. So if you recall what a GP is a sequence with a common ratio. So here the common ratio is we're multiplying the previous term by 1.005, right? So 1 becomes 1.005, becomes 1.005 squared, so on and so forth. So we have 12 terms to work with here. And we learned the formula for the summation of a geometric progression. So this actually equals to 1.005 to the power of 12 minus 1 over 1.005, which is the common ratio, minus 1. Right, so once we have this, next we need to equate this to 0. Because at the start of the 12th month, he hopes to have repaid the entire loan of 12,000, right? So this should be equal to 0. So now do you see we are able to find p? All we have to do is shift this over to the other side. So we get 12000 times 1.05 to the power of 12 equals to p multiplied by the sum of the GP over here. Right, and if we use our calculator, we can get the answer to be p equals to around 1032.80 cents. So actually, don't really need the sign because it's dollar sign p. Alright, so we get an answer of $1032.80. So this is our final answer. So how do we know this is correct? So a rough way to look at it is, if there was no interest, right, if the interest rate is 0%, and he took a loan of $12,000 and he wants to pay it over 12 months, he should be paying $1,000 each month, right? So since there is a small interest rate, the amount he has to pay, the installment he has to pay, should be slightly higher than 1,000 to make up for the so-called losses incurred in paying the compound interest. So this answer would make sense. So if you get an answer like 100 or 10,000 or anything in that range, then it wouldn't make much sense. Okay, so we've come to the end of our explanation to this difficult APGP question. Hope you've been able to understand how to do this, and do stay tuned for our next video.